Hello, and welcome to the lecture on descriptive and frequency statistics. I thought I would divvy up the lectures on describing some of the descriptive and frequency content. And then in the next lecture following this, go into some hand calculations, and then also some SPSS demonstrations. So in this lecture, I'm just going to cover the content. And I think I've covered this or at least part of this in another lecture on the intro to statistics, but I thought I would just cover it again. You can't have too much covered on statistics. So let's get started. Descriptive statistics is somewhat of a broad category. But really what descriptive statistics are doing is just to purely describe the data in terms of what you have. There's no inferential statistics being done here to compare things or to relate things together to see if there's statistical significance in relationships or differences. We're basically just kind of showing percentages. We're showing also how scores are lie on in terms of how close they are to the mean in terms of so that's really what we're looking at. Now let's get into the first, I guess, part of descriptive statistics, which has to deal with central tendency, variability, normality, and maybe even just a spread of the distribution. These are all constructs that deal with more continuous forms of data. So so you need variables that you can calculate a mean score in order to calculate all of these types of descriptive statistics. So we're going to start with central tendency, which is really, we're going to focus in on the mean, because I'm not going to get into much of the median and the mode, because those might be more related to frequency stats, and really the mean is what we really need to hone in on when we're dealing with statistics related to counseling. And the mean is really the average of a set of scores, and we'll get into that, and we're going to calculate that both by hand and in SPSS. And then we're going to look at not only central tendency, we're going to look at variability around the mean. How do scores vary from the mean found in calculated from the scores? And typically there's variance and there's standard deviation. We're going to focus on standard deviation because that's really where that's we need to cut to the chase with that, because that's what's important. So mean and standard deviations are really the two aspects we're going to jump into in terms of being able to calculate those scores both by hand and by SPSS. Deviation from normality, we're going to look at these from an SPSS standpoint, but I'm not going to require you to hand calculate skewness and kurtosis. It's not all that hard, but once again, it's not all that necessary either. So deviation from normality, we have to remember when we calculate statistics, inferential statistics, where we're looking for differences between groups and relationships between variables, that in order to run statistics, the data has to be normalized, has to be have a sense of normality in terms of a central tendency that the bell curve is more normal and not skewed one way or the other, or the bell curve is not flat or peaked. So the bell curve has to be a nice normal shape when in order to run a statistical analysis on it. Also, we're going to look a little bit into the spread of the distribution in terms of maximum and minimum scores and overall range. Once again, all we're going to do is look at that in SPSS, and I'll show you where that is and what to look for. So, all right, let's move on. The normal distribution, this has to do with central tendency and the bell curve. Now, let me just start this slide off with the bell curve is really a theoretical construct that we have about how variables lie in terms of how we understand them. So, I've said this before and I'll say it again. Everything in our profession is theoretically driven. Our theories of personality, our lifespan theories, our career theories, even the psychopharmacology is somewhat theoretically driven because a lot of times we don't know how that medication works. And the math that we use, the statistics that we use, is based on theory as well, because the bell curve is a theory that we have about how we can look at certain variables, and so we need to remember that. And I'm not saying that it's wrong. I'm just saying that it is theoretically based, and we can't we shouldn't be looking at things as factual. We just need to see them for what they really are. And the bell curve is theoretical. So the bell curve is really, based on this normal distribution idea that there's many natural occurring phenomena in the world that produces distributions of data that approximate a normal distribution, which means a normal bell curve. And when I mean normal bell curve, I mean this, that there is I like to call it just like a big hump. And that theoretically, that given let's say a certain, let's give a variable of IQ, and it could be any variable, but related to people. But if we look at IQ, theoretically, 68% of individuals in a population are going to fall within the plus or minus one standard deviations from the mean in terms of IQ. So and then if we move out to the second standard deviation, it goes out another about 20, 13 plus 13 as 20, 26 plus, roughly 27% more people are going to fall within the plus or minus two standard deviation from the mean. And then if we move out to the third standard deviation, we're really looking at an extra 4% that falls within plus or minus three standard deviations from the mean. So it's and that's just how people are distributed within the bell curve. Let's say in IQ, with really with a lot of things, and then what we look at also, we can fit in like T-scores and percentile rankings under the bell curve in order to to conceptualize where people are. So T-scores or Z-scores, and then percentile rankings, and we're going to get into the T-scores and Z-scores more in the psychometrics portion of the assessment class, and also percentile ranking. So I'm going to leave that mostly for that class in terms of that. Okay, now let's move on to frequencies. Frequencies let's see, we're going to look at frequencies, we're going to look at the graphic representation of frequencies, and then get into histograms and percentiles. Frequency statistics under more of descriptive types of statistics. This is one of the more useful forms of SPSS. It's very simplistic, but it tells you a lot about your data. And it sums up the numbers of instances within a particular category. This is used more for variables. So if, let's say, you ran some kind of a study, you could put into frequency form to describe that maybe there were 56 males in your study and 37 females. And then you would be able to run percentages of, how many females, out of, that, and how many males. So it's very descriptive, but it just tells you that, the basically how many, in terms of number form. There's no calculation of averages or standard deviations within frequency data. It's just giving you the numbers. Another example could be that 28% of individuals in your study responded yes to item 11, and 53 responded no to item 11. So it's giving you that kind of data that can be very useful. It's not going to compare anything or relate anything. It's giving you just the very what is percentages and numbers within your data, and that's very much needed. It's not the more exciting stuff when you're comparing or relating groups or variables, but it's very much needed in terms of the basic results when you're describing your results. Bar charts what this does is it creates a visual display of frequency information, uh, 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 and it should only be used with categorical data, not continuous. So this is like, once again, how many females are in your study, how many males are in your study, how many transgendered individuals are in your study, and it'll give you a percentage or a number and a nice little visual of a bar. Or I think you can use pie charts. Whatever you think is going to be best describe your data. All right. Histograms. Histograms are used to display continuous data. And once again, I'm gonna show different examples of these when we do the SPSS. So don't feel like, hey, where's the examples? They are coming. It's also indicate frequencies of a range of values. This is used when a number of instances of a variable is too large and you want to kind of list them all. I don't really use histograms that much, so I'm going to kind of skip over that. Percentiles. This computes any desired percentile for continuous variables. Once again, this is coming off of the bell curve. That if, for example, this is used to indicate whether a percent of a distribution lies below a certain value. So if somebody scored 111 and is at the 75th percentile on that distribution, that would mean that 75% of the values are lower than 111 and 25% are higher than 111. And this is used extensively within psychological instruments. And once again, you're going to be using this in the psychometrics class, and it might become clear to you, as you use more of those instruments in terms of how it's used. Okay, so assessing for normality, as I said before, this is part of descriptive statistics, and we need to understand whether the data set that you are looking at is in fact normally distributed, not perfectly normally distributed, but approximately normally distributed data. So I will go out as far as to say this, and if I said it before, I apologize, but that there's going to be no perfectly normal distribution that you find in the data. I mean, maybe once in a super blue moon would you ever see a data set that has a perfectly normal distribution. You're living in the real world, there's always going to be some deviation from the norm. However, we need to set a standard in terms of what's normal enough and what's not normal enough. And that's what we're doing here. And so really what we're doing when we look at normality, we're looking to assess the skewness and kurtosis of the bell curve. Is it skewed to, is it negatively skewed too much? Is it positively skewed too much? If it is, then we can't really run any statistics on it. If it's not, if it's within a certain parameter, then we'll be able to run statistics. But also with the kurtosis of the bell curve, is the bell curve too flat or is it too peaked? And if it is too flat or too peaked, we can't run any statistics on it. So data has to be normalized before we can move forward, because if it's not, then that's gonna, that could really skew your results when you run statistics. Now, there's different ways that you can assess for normality. And when you assess for skewness and kurtosis, when you actually hand calculate the skewness and kurtosis of a distribution, a data set, you actually will come out to, it will give you a number. And if you calculate it in SPSS, it'll give you a number. And it's called the plus or minus one test. And what this test is saying roughly is that the score, the skewness score and the kurtosis score both have to be within ±1 in order to be considered normally distributed. Now, that's a rough estimation, but typically that's going to be good enough if in order to determine normality. Now, there's also a couple of statistical tests that you can use in order to statistically determine whether a data set is normal or not. And these tests actually have to be insignificant to indicate normal distribution. We have the Shapiro-Wilks test and we have the Smirnov test. Now, it's in the literature, the Shapiro-Wilks test is the gold standard for using, is the gold standard test to use to assess for normality within a data set. And if the Shapiro-Wilks test comes out insignificant, that means that the data is in fact normally distributed. Now, when you read articles and a study does report that Shapiro-Wilks was insignificant, that means that that's a good indicator. A lot of times, though, people will just look for the ±1 rule, and that's also acceptable as well. But Shapiro-Wilks is the gold standard, so that's one that you really want to look for. Okay, so you might be asking yourself, what if you spent a good portion of a year collecting data, and you enter it all into SPSS and you're running the descriptive statistics. You've set it all up, you've cleaned the data, and you start assessing now for normality in the data, and it comes out not normal. Let's say it comes out skewed one way or another. What do you do? Well, there's something called log transformations that you can perform on the data that helps to kind of push the data into a normal bell curve. Now, there's I guess there's a little bit of controversy about this, because people say, well, it kind of shows that, it kind of implies that you're manipulating your data. I don't necessarily think that, but but there are camps out there that I think that do complain about log transformations, I think performing log transformations might be a little bit beyond this, the nature of this lecture, but it's not that hard to do, actually, especially in SPSS. But we'll save that for another time. So, okay, that kind of wraps up a little bit of just a basic introduction to descriptive statistics. And for the next lecture, I'm going to provide some hand calculations, demonstrations on some statistics, and then also some SPSS function. Okay, if you have any questions, please reach out. If not, have a great day.